review what a polar coordinate is, how to find it, how to convert back and forth polar to rectangular, how to graph polar, yada, yada, yada. So, if a point xy is 2 radical 3, then find the angle theta that the line through that point makes the x-axis, and the distance that point is from 0. Well, if that's the xy coordinate, then on the x-axis I'm 2 units out, on the y-axis I'm 2 radical 3 units up. So the question was, how far away from the origin am I? How do you get that?
You can recognize it as a 30, 60, 90, or you can be like...
Perfect. Perfect answer. You can recognize it as a 30, 60, 90, or you could do the Pythagorean Theorem. Either way works. Great. If you happen to have recognized it as a 30, 60, 90, then you've already answered the next question, which is, what is the angle theta that makes with the x-axis? Well, it's 60. If you didn't know that, 60 degrees or pi over 3. Good. If you didn't know that, how could you find it using a calculator if it weren't a 30, 60, 90? Tan inverse of y over x. Right? Those formulas sound familiar from vector information. There's a reason polar coordinates are taught in the same chapter. So a polar coordinate is one where you're given an r and a theta. R is the distance from 0, theta is the angle. One strange thing about it, which this has all the information you could ever need. I don't know that I would write it down. You might just, you know, it's on the PDF file online if you need to reference it. The one weird thing is that r can be negative. Does anyone remember where the point goes if r is negative? The opposite direction. So if it were a first quadrant angle, but r is negative, it puts you down in the third quadrant. Yes?
Do you have clarity, please?
I do.
P has been checked out at the end of the period.
Okay. All right. So polar coordinates, or if P has rectangular coordinates x, y, then P can also be represented with polar coordinates where r is the distance from 0, theta is the angle. So r theta. If r is greater than 0, then P lies on what's called the terminal side of the angle, the normal side of the angle. If r is less than 0, then P lies on the ray pointing in the opposite direction of the terminal side of the angle, so going the other way. The absolute value of r is the distance from the pole. These are 4 formulas you have to memorize. That sounds like let's draw pictures and see what these really mean, because they're really not formulas you have to, I mean, yes, you have to memorize them, but then again, they're, you know. So if we have a triangle in quadrant 1 and we have x, y, and r, does it make sense that x squared plus y squared equals r squared? So I said you had to memorize the formula. You know that one. It's the Pythagorean Theorem. Tangent of theta is y over x. Tangent of the angle is opposite over adjacent makes sense. X is r cosine theta. Let's look at y. If this is theta, then wouldn't you agree that cosine of theta would equal x over r? So you multiply by r. That's where that formula comes from. These are the same 4 formulas you had to memorize for vectors. Do you remember that? And on the vector review day? Except they called this the length of v cosine of theta and the length of v sine of theta. No. Tomato, tomato. Same thing. Okay, any questions about those 4 formulas? You will need them in polar coordinates for converting from polar coordinates to rectangular coordinates and vice versa. Okay, I'm going to do like 1, 2 of these, then we're going to move on. Plot the point by hand, then find rectangular coordinates. 30 degrees, 2 units out. That's how you plot it. Okay, remember that? It's been a while. Convert. Well, if if I know that this is 2 units and I have a 30-degree angle, how can I find x?
X is going to be, it's going to be divided by 2 times the square.
2 cosine of 30 degrees. Does everyone agree with that? Yes. I mean, you're going to end up, you could have done a 30, 60, 90, but in general, y would be 2 sine of theta. So in general, if you have r and theta to get x and y, you do r cosine theta and r sine theta. And as Joseph was saying, because this is a 30, 60, 90, we could find those exact. Cosine of 30 is radical 3 over 2. So that just makes this radical 3. Sine of 30 is a half, so that just makes this 1. Plotting a negative one, this is 2 pi over 3. What is 2 pi over 3? What angle? The 60-degree in quadrant 2. So this is the angle, right? But since the r is negative 4, what do I do? 1, 2, 3, 4 this way. So this is my point Q. X and Y, I'm not going to do anything different. I'm going to do negative 4 cosine of 2 pi over 3 and negative 4 sine of 2 pi over 3. Cosine of 2 pi over 3, isn't that a negative value? Negative radical 3 over 2? Nope, negative 1/2, I lied. Negative 1/2. So that makes this positive 2. Sine of 2 pi over 3 is in fact negative, and it's negative radical 3 over 2. Am I right? I'll check in my work. So I get negative 2 radical 3. Does it make sense to get a positive x and a negative y to match that point Q? Makes perfect sense. It should. If it doesn't, you did something wrong. Is this coming back? It's been a while, but... Did anybody start the homework yet?
Yes.
Okay, so you did all the... I thought it was due today. Oh, it's all due Monday, both that and the book page. Due Monday. Oh, did I say today? I mean Friday. Friday. No, Friday. Definitely Friday. We have calculus homework tomorrow. You don't want to do this and calculus homework at the same time. Yes, the book work and the worksheet are due tomorrow. Did y'all start the book work or just the worksheet? Just the worksheet. Which the worksheet was all calculated, right? Just type it in. Okay, give 3 other pair of polar coordinates. I don't think I'm even going to do that one. I'm just going to tell you how you could, and you tell me how could I find other pairs of polar coordinates. Good, I could add 360 or subtract 360 from the angle, or I could change the r to a negative r and find the corresponding angle that went with that. So we could do that if we must. Okay, backwards. I have rectangular coordinates, x equals -1, y equals 1. I want polar coordinates. How would I find them? I can find either one first, right? Tan inverse of 1 over -1 gives me theta. Now, I do have to be careful. We'll talk about that as we find it. And what gives me r? What's the equation for r? Good. Now, I do have to think a little. Would you agree r could be plus or minus radical 2? Theta, if you type this in your calculator, it's going to give you the equivalent of negative 45 degrees, or negative pi over 4, right? This is in quadrant 2. So how do I deal with that? You have two options there, both correct. Okay, I could add 180 and use the positive radical 2, right? And so that answer would be 135 degrees, or 3 pi over 4 as my angle. And my r would be positive radical 2. What's my other option? Leave it as negative pi over 4 and use the negative r. You have, how many different answers could I put here? Infinitely many. I could go around the circle 100 times if I wished. That would be silly, but I could. So there are infinitely many equivalent polar coordinates. These are the most, probably the easiest two to come up with, but it says 2 pairs. I found 2 pairs. Any questions about why we have to be slightly careful here? Would it work if I put negative pi over 4 and positive radical 2? No, that would be the wrong coordinate. That would be in the wrong quadrant. So just be careful about that with polar coordinates. Okay, these are rectangular coordinates, and I want to write the equation in polar form. You have 4 equations to help you. That's why you need to know these. If you didn't write these down, you need to. So I have x's and y's. I want r's and thetas. So, any ideas? You could, easier than that. You could make it into Pythagorean. Just plug in what? Okay, is that correct so far? Oh, no, it's not. Watch me there. What did I do wrong? Yeah, I put sine twice. Just do a substitution. Get rid of the x and y using r sine and r cosine. Now, I don't know how much we did last year. I think I made you do this last year, but if not, I am going to go ahead and make you solve for r. Why would we want to do that now that you've done some of the homework and seen what your calculator looks like? Why would I want to solve for r? That's like solving for y. That's how you plug in polar coordinates into your calculators in r equals format. How could I solve that for r? Factor out an r. I will. So r is negative 3 over sine theta minus cosine theta. So it turns out that if I were in polar coordinates in my calculator and I graphed that, the line y equals x minus 3 would come up. So now you can imagine if it's that thing, why would we ever change it into polar coordinates? I would think we would probably not want to do that, but it's an option. Okay, let's do the y equals 5. Convert to polar coordinates. Okay, good. What am I doing first? Slow down a little, Joseph. R sine theta for y. And so what is r? 5 over sine theta. You might call it cosecant if you wish, but either way. Any questions about that one? Okay, the last one, x squared plus y squared equals 25. Oh, it's going to be a circle, right? X squared plus y squared is r squared. Everyone agree with that? Now, if you hadn't noticed that and you had plugged in r cosine theta and r sine theta and squared them both, you could have factored out an r squared and you would have had sine squared plus cosine squared, which is 1, you'd land in the same place, it'd take you longer, but you'd get there eventually. So r equals 5. Technically it is plus or minus 5, but r equals 5 will generate the same thing as plus or minus 5. You're saying r, the radius, is always 5. Won't that generate a circle on a polar graph? Makes sense. Backwards. Write the polar equation in rectangular form. Don't say anything, think for a second. By the way, your quizzes, the scores on them, I haven't come back yet or talked about them yet for instructions, but they are on headline. Tomorrow is just this. Anybody have a class with Aaron 6 out? Anyone? Aaron? Okay, polar equation in rectangular form. I could replace r with some nasty square root if I wanted to, then I still have the sign there. So I'm trying to figure out a way to get rid of both of those at the same time. As you know, with any equation, you can do anything you want to both sides, right? I like the idea of multiplying both sides by r. Why do I like doing that? R squared's good. R sine theta is good, right? I get x squared plus y squared equals 2y. I'm going to spare you the solving on that. It is a conic section, but just for time purposes, we're just going to leave it like that. It's question. Is this equation nicer in polar or rectangular coordinates? Polar. This equation was nicer in rectangular coordinates. You can see where this is leading us with calculus is which one's easier to integrate, which one's easier to differentiate. Where would we want to land on which coordinate system would be easier for us to work with? So that's kind of where this is heading, as you can imagine. Square both sides. Makes perfect sense, right? So that's converting polar to rectangular, rectangular to polar. That's like 2 days of trig calc in one. Okay, how are we doing though? We doing okay? I know we're going fast, purposeful, but if you need to slow me down, ask. Intersections of polar graphs. I'm going to skip the first one just because it's too easy. How do you find intersections of normal graphs? Set them equal to each other, or do substitution or elimination or whatever works easiest. So what am I going to do in polar coordinates? The same thing. These already have r by themselves, so that makes life easier. You see why I skipped the first one. It already told you r was 4. It was just too easy. 6 cosine of theta equals -1 plus 4 cosine of theta. The only difference in rectangular and polar coordinates on finding intersections is that you'll have to solve some trig equations. Other than that, it's the same thing. How would I go about solving this trig equation? All the cosines on the same side. I don't know, which one do I want? So there's more than one intersection, is what you're telling me. So I want both. If I were doing rectangular coordinates and a graph intersected twice, would I want both? I want both. All intersections from 0 to 2 pi. Cosine is negative in the second and third quadrants. Everyone agree those are the 60-degree angles? So 2 pi over 3 and 4 pi over 3. Anyone need me to slow down on how I got those angles? Grant, I know I do that completely different than you learned it. Are you okay with that? Okay. What else do I need if I wanted a point of intersection? I need the R value. How would I go about finding that? Plug both of those in. You can do it in either equation. If it were this problem, which one would you choose? The one on the left, I don't have to add or multiply. Well, I have to multiply, I don't have to add. Would you agree cosine of both of these angles is negative 1/2? So I'm going to shortcut. So R on both of them would be negative 3. So the point of intersection there is negative 3, 2 pi over 3, and then negative 3, 4 pi over 3. So that is how you find intersections of polar graphs. If the problem's in polar coordinates, it'll be a polar coordinate. Yeah. What we're going to use this for in calculus is integration. And the reason we would find intersections is we're going to find area under between polar curves. And so you would need intersections to know where to integrate from and to. So if your integral is d theta, you would use the theta intersection points to go from and to. So that's where this is heading and why we are. There's a rhyme to my reason on why I made you do this in trig calc. It's a skill they expect you to know because you have to find intersections, just like in rectangular coordinates, to find area. Yes, think of all of the applications of area that we could find, which is a lot. Make things, model things. It could even be velocity, and your area is distance, right? So there are a lot of applications of area. Now think about our world. Is it flat and cornered shaped? It's a big circle. So there are a lot of real world curves that happen to fit polar better. Now, where we go with this physics-wise, real-world-wise, is which one's better for you? Well, it depends. Depends on the curve. And so you can choose polar coordinates for something that fits better. Way beyond what we probably need to talk about, but we'll say it anyway, is obviously our world is not two-dimensional. That's where Cal 3 comes in. You do three-dimensional coordinates, and instead of polar coordinates, you have spherical coordinates. And so you have an x, y, and z axis. If you look in rectangular coordinates, spherical coordinates, you can... so anyway, so there's lots of real-world applications. Probably a lot more than I know. But that's what I know. So Cal 3 pretty much is Cal 2 again with a third dimension tacked on. No. So those of you who will take Cal 3 next year, it actually turns out to be the easiest of the 3 calculus classes because it's all the same stuff. Just you throw in a z and do everything the same, pretty much. You'll learn that next year. Maybe, if you have to take it off. Those are engineers, chemistry's done it too. Engineers and computer scientists, maybe. Okay, this is probably the last one we will do. I just want to do this one because the solving is a little tricky. You have some options. There is not one correct way to solve this, and it's not as bad as it looks at first glance. Whoops. I need to quit writing cosine as sine. That's a bad idea. You can do whatever you want to do. Yes. Okay, I heard several great ideas. I heard, can I divide by cosine and call it tangent? Who said that? Someone said that. I know I heard that. I didn't make that up, because I wouldn't have thought it. Okay. Can you do that? Sure. Tangent equals 1. And then you probably know when tangent equals 1. Can you just think about when sine and cosine are equal? Sure. You can do that. The solving principal way is you would square both sides and use a trig identity to change one into the other one so that you can get them by themselves. Anytime you square both sides, you have to check all your answers. So I like your choices better. However you do it, you get pi over 4. And what other one? 5 pi over 4. Why 5 pi over 4? Third quadrant, both sine and cosine are both negative. So a negative over a negative makes that positive. And then plug that in. The R value is 7 plus sine radical 2 over, or 7 plus 5 radical 2 over 2. Is that right? And that would, nope, it's minus. Sine, no, that first one's positive. Pi over 4 is positive. But the 5 pi over 4 would, the only difference would be that would be negative. That, right? So, any questions about those? When you plug in 5 pi over 4, Aaron, the sine of 5 pi over 4 is in the third quadrant, so it's negative. So when you just go plug that in. So it's 7 plus 5 sine of 5 pi over 4. Right. Just because sine of 5 pi over 4 happens to be negative radical 2 over 2. You probably have those memorized a little better than we do. We're picture drawers. But memorization is faster, so that's good. Okay, graphing by hand. You did this in the calculator yesterday, or if you haven't yet, you will on that assignment. In the calculator, you just type it in. One thing to be aware of is your window. As always, when graphing, window is an issue. Make sure your thetas match your mode. For example, if you are in degree mode and your theta is from 0 to 2 pi, are you going to graph very much? What is 2 pi? How much is that?
It's supposed to be 360 degrees, but it's 6.28.
Right, so you're gonna graph all the points that fall between 0 and 6 degrees. You're not gonna go very far. Does everyone understand that about your window? So if you're graphing in the calculator, make sure your window matches your mode. If it doesn't, fix it. Theta step is another issue sometimes. Does anyone remember what theta step is? How often it plots a point. So if you're in degree mode and you do a theta step of 1, you get a point every 1 degree. It plots a pretty good graph, and it does it pretty efficiently. If you put 0.01 in degrees, you get a beautiful graph, but you're going to be sitting there watching it draw for a while because it's plotting a point every 0.01. If you are in radians and you put 1 as your theta step, you're going to get a very jagged looking graph. Why? It's only plotting a point every 1 radian. There are only 6 all the way around. So it's only plotting 6 points and trying to connect the dots. Your calculator does a horrible job if you do that. So just be aware of your window appropriateness for your mode. That makes sense? Okay, now we're going to do a couple completely by hand. On the AP Calculus exam, it is rare for you to have to graph by hand. It does occasionally come up. Why does it come up? Well, they may ask you to find area completely by hand. In order to do that, you would have to have an idea of what you're finding the area of. Now, it doesn't have to be a perfect sketch, but we need an idea of what we're graphing, right? So, what do we do if we don't know what it looks like? We point plot just like from Algebra 1. A lot of people, this at first glance kind of scares them, like, I can't do it. Yes, you can. You did it last year. I made you do this by hand last year. So you can do it. It's tedious. We will only do it this way if we must. If it's a calculator problem, use it. But if not, we will point plot as necessary. So I'm going to graph 1 completely by hand. Obviously, if I have to go completely by hand, what am I going to plot? Unit circle points. And I'm even going to choose wisely on my unit circle points, right? I'm going to pick the ones that work out nice. Cosine of 0. Can I do that?
Yes.
What is cosine of 0? 1 plus 1 is 2. Cosine of 30 is a little bit tricky, right? Square root of 3 over 2 plus 1. I don't know exactly what that is, right? 1 point something. And I'm going to leave it like that. 1 point something, right? I don't know exactly what it is. My graph doesn't have to be perfect, remember. I'm just getting a good idea. Cosine of 45 is radical 2 over 2. That's 1 point something, a little less. Would you agree? 1 point something again. A little less than that one, so I'm going down. Okay, cosine of 60 I can totally do. What is cosine of 60? Yeah. So it's probably like 1.8 and 1.7. I don't know, but, right? Then there's 1.5. I don't have to know. I just need to kind of know what's happening here. Cosine of 90. Good. 0, and so I get 1. Cosine of 120. Isn't that the same as cosine of 60 except negative? So it's negative 1/2, right? Did I do that? Did I? I wasn't adding, was I? They're not letting me do that, huh?
It's 1/2 is 1.
Oh yeah, okay, good. Okay, so and then, so 1.5, is that what we got? 0.5, there we go. I'm glad y'all are taking care of me. We're gonna blame that on pregnancy, but I'm sure it has nothing to do with it. Just can't add. Okay, and then 135, so it would be 1 minus radical 2 over 2. Radical 2 over 2 is a little under 1/2, so, right, so point something bigger than 1/2, right? All right, 150, that one I can do, can't I? Isn't it negative 1/2? So 1 minus 1/2 is positive 1/2. Cosine of 180 is negative 1, so I get 0. Do what? I don't know, maybe.
Yes, it should be because you're going.
So it's 0.3 or something. Sounds good. 210, that's a 30 degree. It is still negative, right? So whatever 150 was, 210 is the same thing. 240 the same as 120. Yeah. Because it's a 60, except quadrant. Do what? Steps. 240's down here. It's the 60 degree, right? Everyone agree? 1, 2, radical 3. That's negative, so negative 1/2. 1 minus a half is 0.5. Cosine of 270 is 0. Then I go backwards, I'm going to get some of the same things I got up here, aren't I? 1.5, 1.7. And probably wouldn't be a bad idea to go ahead and do 360. Isn't it going to be 2 again? From there, I'm going to repeat. I'm going to plot all those points. 0, 2 units out. I'm going to skip the 30 and 45, see if I can't connect the dots, but I kind of know what's going on. At 60, I'm at 1.5. So you see how I'm going to just kind of follow to that. I'm going to decrease on my way there. 90 is 1. 120 is 1/2. 180 is 0. You see how I'm skipping all the ones I don't really know? 270 is 1/2. 270 is 1. Sorry, 240 is 1/2. 270 is 1. 300 is 1.5. And then 360 is back here. See the shape? You do go in order, by the way, of how you plotted. Oops. Notice the name of this graph. It's a cardioid. We graphed it. It was tedious, yucky. Was it hard? It took us forever. It will always take you forever. Now, we could do the same thing with this one. We'd get a rose. We could do the same thing with this one. We would get a lemniscate. Notice on this one, my table skips a lot of values. The reason it does that is cosine is negative in a lot of those places. And if cosine is negative, can you get R? No, it wouldn't work. It'd be undefined. And so it truly is just not defined at those points. Lemniscate, it looks like an infinity symbol. Now, what you can do is you can have an idea of what these look like. This is I think this is in your textbook. So I don't think you have to write it down. If you regret that decision later, you can get it on Edline. But any graph in the form a cosine of theta is a circle. A sine of theta is a circle. A cosine theta is a circle to the right of the, or left, depending on A. A sine of theta is a circle centered above or below. A squared sine of 2 theta equals R squared is a lemniscate that is a diagonal. A squared cosine 2 theta is a lemniscate that looks like an infinity symbol. These are called lemmastones. Special cases of them are called cardioids, the ones that look like hearts. That's the last one we drew. A plus or minus B sine theta, A and B are just numbers, and A plus or minus B cosine of theta. These do occasionally have loops in them. Finding where those loops are is sometimes very important, because sometimes they'll ask us to find the area inside the loop. So we'll talk about that later.
You're never going to guess, like,
Do what?
or you're going to guess.
No, you will never be asked to name them. Now, they may, yeah, so I wouldn't memorize the names, but they may give you hints with the names. Like they may say, find the area, a common question is find the area of one petal of this rose. So that's a question that, did you hear me, Patrick? So that's a question you could be asked. They will never say, is this a rose? But they may ask you to find a petal. Again, we'll do the calculus tomorrow. Today we're just doing the pre-cal part. You already have this homework. This is your homework. 564, 2 through 30 even, and graphing polar equations. Now the good news is a lot of the polar area questions fall on the calculator part. Just the bad news is not all of them. A lot of them do. Every now and again.
But does it mean if something goes to the pole, is that like the word?
Yes, the pole is another word for the origin. The pole is the origin. Did this come back? Any questions about it? We covered like 4 days of, look in the box back there. We covered like 4 days of trig calc in 1 day. Trig calc was already fast, so be okay? I'll take the talking to mean yes.